All right, welcome back. Our last video was a quick introduction to the fundamental theorem of calculus, um, sometimes abbreviated FTC, and this was the evaluation part. And in case it's been a bit of time since you watched, remember we could find the integral from a to b of f of x dx by finding the antiderivative evaluated at b and subtracting the antiderivative evaluated at a. So we're going to look at a quick example to tie this to area. And so this is example 6 in this chapter. And let's look at the function y equals 4 minus x squared. We are interested in the area between this function and the x-axis. And we are interested in the interval from 0 to 3. So quick sketch of this: 4 minus x squared, vertical shift of 4, parabola going downwards. And what we see is that here is the area that we're interested in. Notice that we have a portion above and a portion below the x-axis. So the first thing we could do would be to just do a quick calculation. We'll throw this into our calculator. Integral from 0 to 3 of 4 minus x squared dx. And when we do that calculation, we get 3, and we say, great, I'm so happy. I have figured this out. I can move on to the next question. Then I recognize that, well, I got a bit of a problem here because this area is going to be greater than 0, and this area is going to be actually less than 0, which I know isn't really a thing, having an area less than 0. So I wonder whether that 3 is actually accurate. Maybe that 3, since it is the calculation of an integral, is actually this positive number minus that number instead of plus that number. So what we're going to do is we're going to start over again. We're going to say, well, let's go from 0 to 2 because I know that that's all positive. And then let's calculate what happens between 2 and 3 because I know that that's going to be negative. And when I do this, I know that the antiderivative of 4 minus x squared is 4x minus 1/3 x cubed. I'm going to evaluate from 0 to 2, and what I get is 16/3. And when I evaluate this antiderivative, 4x minus 1/3 x cubed, from 2 to 3, what I discover is that, in fact, this evaluates out to negative 7/3. Well, my actual area between the y equals and the x-axis is going to be the absolute value of each of these sections. And notice that this is 23/3, which is significantly more than 3. So we've got to be really, really careful that when we're plugging things into our calculator, my students routinely will ask me, well, Mr. Hermiting, if we can just plug it into our calculator, then, why do we need to be able to do all this stuff? Well, there you go. So quick synopsis of what we need to be careful of is that we need to partition our function and we need to partition it at the zeros so that we can add the absolute values to find area. Now, keep in mind that if somebody says, hey, what's the integral from 0 to 3? Well, it's 3. But if somebody says, what's the area, then, of course, we have to split it up and we get a completely different answer. And it turns out that you can actually shortcut this process. If you want to find the area, you can just tell your calculator to find the absolute value of that integral. And in fact, it will rush off and do that for you. So there you go. I've shown you the reason that we can't just use the calculator integral without thinking about it. And I have shown you how we can use the calculator integral without thinking about it. But of course, the takeaway really needs to be that it's a really, really good idea to think about what you're doing before you just start shoving things into the calculator. Otherwise, you're likely to get completely wrong answers, and then you won't know why. All right. Thanks for watching. I hope you learned something.